Last class we did the sum and the difference of angles. Now what about double the angles? Well, we have sine 2 alpha. We have cosine 2 alpha. And down there I'm leaving a space. We have tangent 2 alpha. Well, there's only one for sine 2 alpha. If you see sine 2 alpha, that's 2 times sine alpha cosine alpha. Cosine 2 alpha, you can break it down to cosine square alpha minus sine square alpha. So this is one of them right here. I'll put a check mark next to it. See if I have a red color. Check mark. That's one. But I can derive actually two more out of this. Remember, last class we said, I'll put this here, clean sheet. If you remember last class, well, I'll put it, you know what? I'll put it with the rest of the notes. Last class I said sine squared alpha plus cosine squared alpha is what? Isn't that a 1? So if I move the cosine squared to that side, you'll have sine squared alpha equals 1 minus cosine squared alpha. Or if I move the sine squared to that side, you can have cosine squared alpha equals 1 minus sine squared alpha. So when you look at the cosine, there's always three identities, three of them. Why three? Because they play with the algebra. They go, you know what? Let's take that cosine squared. Let's replace it with 1 minus sine squared. That's this one. That's what cosine squared is. Minus, and there's the sine squared. And you're going to have what? Now you'll have 1 minus 2 sine squared alpha. So that's another one you'll see in a math book, that cosine 2 alpha is equal to this, or it's equal to that one. It's the same thing. Or if you decide to keep it, again, here we go. It's cosine squared alpha minus sine squared alpha. What about if you decide to leave this one alone, but in place of sine squared, let's put what? 1 minus cosine squared alpha. What would you have here? This is, notice that's a minus 1 plus cosine squared, plus. So you'll have 2 cosine squared alpha minus 1. So these are the three equivalents of cosine 2 alpha. So it's this one, or that one, or this one. You can use any one of them. Which one you want to use? It depends which one makes the problem easier. We'll do some examples shortly. What about tangent 2 alpha? Tangent 2 alpha, it's 2 times tangent alpha, there's only one of them, over 1 minus tangent squared alpha. So these are the three identities that I need: sine 2 alpha, cosine 2 alpha, and tangent 2 alpha. Again, add that to the list of inequalities that you have there. Put them on that page there, so when you're looking for all the trig identities, you have them all in one spot. Let's take some examples here and see what will happen. Everyone's done? I'll wait till you finish writing. Let's take this example. Let's say I gave you cosine alpha. We don't even know what alpha is. Equals. Pick a fraction. Less than 1. What? 1/2? Well, let's do 1/3. 1/2, I know the angle for 1/2 is 60 degrees. So cosine alpha equals 1/3. I have no idea what that angle is. The question now, can you tell me what is cosine 2 alpha is equal to? And let's assume we are in quadrant 1. And can you tell me what is sine 2 alpha while we add it? And what is tangent 2 alpha? Now I'm combining the lecture from 2 classes ago with today. We are in the first quadrant, because I said in the first quadrant I could have picked all students take calculus, could be in the fourth when the cosine is positive. So we're in the first quadrant. There's my angle. I have no idea how big the angle is, and I don't really care to know. This is alpha. The cosine, what sides? What's the cosine? Adjacent over the hypotenuse. Yes, so that's the 1, that's the 3. My scale is not really correct there. The angle should be bigger if you want to do the right scale. But it's not a big deal. Can I find the height? Because I need that for part 2 when you're looking for the sine. Or even for the first one. So now I can use Pythagorean's theorem. 3 squared equals 1 squared plus y squared. What's 3 squared? Oh, 9. I know the answer is 8 already in my head. My subconscious already telling me. 9 equals 1 plus y squared. Subtract 1 from both sides. And y will have to be the square root of 8. Can't be negative because it's above in the first quadrant. You can simplify the square root of 8. 8 is what? 4 times 2? So y equals what? 2 the square root of 2. So now I know the sine, I know the tangent. What is sine alpha? Sine is opposite over what? Hypotenuse. Tangent, opposite over what? The adjacent, which is 2 the square root of 2. So I know what the sine is and I know what the tangent is. So cosine 2 alpha, I have 3 choices to choose from. I can use this one, I can use this one, or I can use this one. I will choose that one. Why? Just in case I made a mistake finding the sine. This one does not use the sine, just use the cosine. They gave me that value. So that's a safer bet to use. So that's going to be 2 times The cosine is 1/3. You need to square that. Minus the 1. 1/3 square is what? 1/9 times 2? That's 2/9 minus the 1. Well, the 1 is 9/9. Because if you want to add or subtract, you need your LCD. What's 2 minus 9? Negative, right? Twice that angle is going to put it in quadrant 2 here. So that's why the cosine is negative. Now the sine is going to be positive. Why? Because that's going to be in this quadrant again. In this quadrant, the sine is positive. Let's see what's sine 2 alpha. Well, it's supposed to be 2 sine alpha cosine alpha. There's only one rule for that. That's 2 times. We know what's sine alpha. I just calculated that. 2 the square root of 2/3. I know what cosine alpha is. That's 1/3. Do the math. That's what? 4 the square root of 2 divided by what? 9. And it's positive. What about tangent 2 alpha? 2 times tangent alpha over 1 minus tangent alpha square. Two times, I know what tangent alpha is right there. It's 2 the square root of 2 over 1 minus 2 the square root of 2 squared. Two times 2 is 4. The square root of 2 divided by what? 1 minus. Square that. That's an 8. Because 2 squared is 4. When you square a square root, you lose it. 4 times 2 is 8. That would be a negative 4 the square root of 2 over 7. I put the minus in the front. Again, you in this quadrant, all students take calculus. All stores take cash. Sine is positive here. You're going to be in this one. Only the cosine is positive. The rest of them are negative. Negative and negative. So that's the sine of 2 alpha and the tangent of 2 alpha. You get the answer to each one. I'll keep the first page handy because I will need it. But let's try another one. Cosine alpha equals what? 3 over 5. And now we are in quadrant 4. Quadrant 4. Let's do the math here. We are in quadrant 4. So somewhere there is alpha. Again, the cosine is the adjacent, which is this one, positive, over the hypotenuse. That means y is going to be negative. Remember, all stores take cash. Only the cosine is positive in this quadrant. Now when you double that angle, when you double, it's probably going to be right here. So in that, only the tangent is positive. The other two will be negative. So let's find the y value. 5 squared equals what? 3 squared plus y squared. Pythagorean theorem. 25. Bless you. 7:40 is too early a.m. 25 equals 9 plus y squared. Y squared equals 16. Y will have to be plus or minus. In this case will be negative 4, because you can see it's down there below. So now I know my sign here is going to be the opposite, which is negative 4 over 5, the hypotenuse. And the tangent is going to be the opposite over the adjacent. So if the question was, what is sine 2 alpha? You go, that's easy. That's 2 times sine of alpha cosine alpha. Two times, we know what the sine of alpha, I just did that, negative 4 over 5. The cosine of alpha, 3 over 5. That's a negative 25 in the bottom. 2 times 4 is 8. 8 times 3 is what? 24. The cosine of 2 alpha. Again, I don't want to make a mistake. Since I was given the cosine, I'll stick with that one. 2 times cosine squared alpha minus 1. 2 times cosine alpha is 3 over 5. Square it minus the 1. 9 times 2, that's 18 over 25 minus the 1. Well, the 1 will be what? 25 over 25. That's what the 1 is. 18 minus 25, which is what? Negative 7 over 25. Remember, my angle was in this quadrant. Twice that's going to put in that quadrant. Only the tangent should be positive. These two guys should be negative. So far it's telling me I'm on the right track. Let's see if the tangent is positive. Two times tangent alpha over 1 minus tangent square alpha. Two times negative 4 over 3, 1 minus negative 4 over 3 squared. Negative 8 over 3 divided by 1 minus what? 16 over 9. And you can write the 1 as what? 9 over 9? So I will take the 1 now and turn it to 9 over 9. That's what a 1 is. So do the math. Negative 8 over 3 divided by, what's 9 minus 16? Negative 7 over 9. Division becomes multiplications if you do what? If you flip the second one. I can divide by 3 to make my life easy quickly. The minuses will cancel, but negative 24 over negative 7, which is 24 over 7. Okay, let's try a few more examples, different ones. Let's say we ask you to simplify. I'll let you finish writing. The question was simplify. And this way I have 2 divided by, can't see the problem. Let me make it bigger. Oh, let me zoom in here. 1 plus cosine 2x. I have 3 options for cosine 2x. Let me write them down. I said earlier cosine 2x could be cosine squared x. I use alpha before, I can use x, doesn't really matter what we use. I can do this, or I can use this, or I can use 2 cosine squared x minus 1. I can use any one of them. Now if I look at the bottom, I'm trying to simplify the bottom. Well, if I use this one, the cosine square minus sine square, is that going to make the bottom simpler? No. So that maybe that's not a good option. What about if I use the second one? Probably not, because this becomes 2 minus 2 sine. What about if I use the last one? Let's try that. So in place of that, let's put 2 cosine squared x minus the 1. And what happens to the 1's now? They will cancel each other out. This one and that one, they'll cancel. So now I will have what? 2 divided by 2 cosine squared x. The 2's will cancel. When you cancel that, there's always a 1 left there, not a 0. Because if you have a 0 on the top, the whole thing is 0. And what is 1 over cosine, we know? Because you can write that 1 over cosine x, the whole thing squared. 1 squared is still 1. Cosine squared will give me that one. What's 1 over cosine? Secant. And you gotta square it. So the answer to that, if you simplify it, it is secant squared x. I'll try a bigger one. How we doing? Good? Sine 3x over sine of x plus cosine 3x over cosine x. I want to simplify that. Can I simplify these? Just looking at that, can I cancel anything? Make it sine 2x? Nope, you can't. This is like having sine 60 degrees over sine 5 degrees. You can't cancel. Now, we have no rule about triple the angles. We never cover that. There's nothing. I showed you double the angle. If that was a 2, I could. If that was a 2, I could, but not a 3. So both ideas are gone. There's only one idea left there for me. And that's I'm adding fractions with different denominators. If you want to add fractions with different denominators, the first thing you have to do is what? Find the LCD, which is sine x cosine x. Now notice this one is missing what? The cosine. So I will multiply the top with the cosine. So sine 3x cosine x. This one is missing the sine. That would be cosine 3x sine x. It doesn't look promising yet. Make it one fraction, and we will have what? Sine 3x cosine x plus excuse me, cosine 3x sine of x. We covered this topic in the last class, last video. We said if you let alpha equals 3x, beta equals x, you can write the top as what? Sine alpha cosine beta plus cosine alpha sine beta. Now, which trig identity is that? Sine alpha cosine beta plus cosine alpha sine beta. Wasn't that sine alpha plus beta? So if I use that, what's alpha plus beta? Alpha is 3x, beta is x. What's 3x plus x? 4x. Get a little bit smaller, but still not happy with it. Trying to hope to cancel something in the bottom. That's what I'm hoping to. How am I going to cancel? I can't cancel sine x with sine 4x. Again, this is like sine 20 degrees in the bottom, sine 80 on the top. Can't cancel them. Any idea? Notice I can take the 4x and write that as 2 times 2x. twice that number. And if you recall, I have an identity that says sine 2 alpha is equal to what? 2 sine alpha cosine alpha. Maybe I can do that here. Except my alpha here is 2x. That's what my alpha is. So I can write that 2 times sine 2x cosine 2x. I'm making progress, but I'm not there yet. I didn't expect this problem to be this ugly. I should have made that a minus. That would have been a lot easier. So now I can do cosine 2 alpha or 2x again. And I can do cosine 2 alpha or 2x again. So if you break that one more time, I'm not done with it, so that would be what? 2 times, what is sine 2x? 2 times sine of x cosine of x. You know, actually that's good. Cosine 2x. Leave the cosine 2x alone for now. So I just took the sine of 2x, replaced it with this. Does anything cancel here? Look at this, this, and that. What's 2 times 2? 4 times cosine 2x. And if you want to open cosine 2x, go ahead, but that's fine. That problem would have been much nicer if I made that a minus in between them. Because you end up with sine 2x here, and you end up with the 4 at the end. Because it would be 2 sine x cosine x, you end up with just the number 4. So all of that will simplify to 4 if that was a minus between them. Let's try some more problems. A few more. Simplify. I'll get another, I don't know. I don't even know if they're ugly or not. Honestly, I have no idea. I'm not even sure how I'm going to approach it, but I'll look at it and see. 2 plus cosine 2 theta over sine squared theta. I need to simplify that. Well, I know for cosine 2 theta I have 3 options right here. Where is it? Cosine 2 theta is equal to cosine squared theta plus, or not plus, it's minus, where's my eraser? Minus sine squared theta. Or I can use what? 1 minus 2 sine squared theta. Or I can use 2 cosine squared theta minus 1. So we can use any one of them. Which one you want to use? Choose one, we'll try it. First, second, or third. You pick one. Because when you're doing the homework, especially in your case, sometimes you're not sure which one to use. So I'll be you. Which one you want to use? Second? Okay, second one. The 2 is 2 over 1, right? That's what a 2 is. Again, you want to add, subtract fractions. What do you need? Don't we need common denominator? And what's my common denominator here? Sine squared. So this one I don't have to touch it. It's fine. This one I gotta multiply it by sine squared. That'll be what? 2 times sine squared theta. Now if you combine them together as one fraction, you'll have what? 2 sine squared theta plus the 1 minus 2 sine squared theta. Any cancellations on the top? Anything canceling? These two. One is positive, one is negative. So what's left? 1 over sine squared theta, and you can write that 1 over sine theta, the whole thing squared. 1 over sine is what? Cosecant squared theta. I'll try one more. What time is it now? 35. Simplify. I'll combine this section with the previous stuff. This is cosine of x minus tangent x sine of x, all of that divided by secant x. And again, you know my style. I'm going to change everything to sine cosine. Oh, as I'm going to change to sine cosine, I start writing secant. Secant is what? Isn't that 1 over cosine? Cosine here. Tangent sine over cosine. Times the sine. Bottom is good for now. This is cosine x, or cosine x over 1, minus, this will be what? Sine square x over cosine x. Again, if you're going to add or subtract, you need an LCD. Or problem like this, you know what's the easiest way? To get rid of all the little fractions, multiply every term by the LCD. Let me multiply by cosine of x. Let me multiply by the cosine of x. Let me multiply by the cosine of x. Cosine times cosine, that will make it what? cosine squared x minus, these two will cancel each other out. You end up with what? Sine squared x. These two will cancel each other out. You end up with the 1 in the bottom. When you have a complex fraction, that's probably the quickest way to clean it. Multiply every single thing by the least common denominator. So here's my answer. Cosine squared x minus sine squared x. Oh, wait a minute. What was cosine 2 alpha? Isn't it cosine squared minus sine squared? So if I work it backward, I can write this as what? Cosine 2x.
So which is the more simplified?
Probably single. They're looking at usually they're looking for a single trig identity. That's what they are looking for. A couple more examples and I'm done. What about if you have this problem? Simplify. Four sine squared x cosine squared x. Now remember, we have a trig identity that says sine 2x is equal to what? 2 times sine of x cosine of x. Can I use that here? I can write this problem as 2 times sine of x cosine of x, the whole thing squared. What's 2 squared? 4. Take the sine squared, sine squared. Take the cosine squared, cosine squared. What is 2 sine cosine equal to? Sine 2x. Don't forget to square it. And we normally, the way we write this, we go sine squared 2x. Or you might see simplify. One minus 2 sine squared 4x. It's a different problem. Well, let me look. Just got my attention. 1 minus 2 sine square. That looks like one of the identities for what? The cosine. See that? So I have cosine 2x equals 1 minus 2 sine squared. Well, let me use alpha. Actually, I use alpha here. So let me just put alpha here. Cosine 2 alpha equals 1 minus sine 2 sine squared. I have the 1, I got the minus, I got the 2, I got the sine squared. So when you compare these two together, when you compare them, that tells me, you know what? This is really my alpha when you compare the two of them. So my answer should be what? Cosine twice that angle. So my answer should be cosine 2 times alpha. But what's alpha equal to? Cosine 2 times alpha happens to be 4x. So your answer to this question should be cosine 8x. So you can take that problem now and change it to cosine 8x. I'll stop here. We had enough, I think.